The following program is sponsored by the Building Wisconsin Television Network.
Welcome to Building Wisconsin. I'm Stuart Keith, and on today's show, we're learning more about what's being done to protect our water supply. So let's get started with Scott Hamilton from ASSE International. Well, Scott, you see this wall full of faucets here, and I, like so many people, tend to take water for granted. And we're fortunate here in the upper Midwest, especially Wisconsin, surrounded by the Great Lakes. And fortunately, there are organizations and people looking out for our water supply, and that's why we can literally take it for granted.
Yes, Stu, as the society is changing, we're getting more with water being one of our number one resources and moving towards a more green society and using water smarter. It creates more potential hazards, and organizations such as ASSE and others have gone through great measures to both protect the products and protect the end user to make sure that the water stays safe, and our number one resource is always going to be there for us to use in the future.
Okay, so as I look at a wall of faucets or fixtures or valves up here, what is ASSE doing to protect the general public?
Our two main subjects that we get into is backflow protection and scald awareness with thermal mixing valves. This we're looking at right here is a shower mixing valve. And what we're concerned about here is you're mixing hot and cold water. We want to make sure that the mix is going to be something that when the end user gets hit by that water spray, isn't going to scald them, isn't going to put them in a thermal shock. So we write a standard for the product, first of all, to make sure that it's going to do what the manufacturer says it's going to do, and then we run it through a series of tests. When it passes all those tests, then we put our certification on that product saying to the end user and whoever else in the public is going to use it that this will protect them from scalding or thermal shock, and therefore it's going to be safe for them to use. Inspectors know that's going to be safe. Then when the plumber installs it, they know what to look for. They know that this is going to be a good quality product.
Boy, that's a great service and something that's, very necessary out there, especially when you think all the hazards out there. Now, another area you said was backflow prevention. So let's first explain situations where backflow might occur and why we should all be concerned about that issue.
Backflow is actually something that most of society takes for granted that it doesn't happen, and it's because of these assemblies that we put on. But if you think about it, golf courses that put pesticides all over the greens and make them nice and green, they have underground sprinkler systems that pop up and spray water. Without backflow protection, those pesticides can get into the drinking water and into society's potable drinking water. In the home itself, same thing applies with a hose. You put a hose down in a muddy puddle or you put it into a soapy bucket that you're washing your car with. And what you're looking for is whether there's a high demand on the source side of your water system.
So backflow, in essence, is we have flow leading into the house. We're talking about when that flow reverses and sucks all that nasty water that's in the house, all the wastewater, whether it's you're washing your car and you have the bucket like you alluded to, yes, or your toilet or anything else in your house. You don't want that getting back into the public water supply, or if you're on, maybe you have well water, you don't want to contaminate your own well or the aquifer, that's for sure. So backflow, flowing backwards into the supply. And that's what these assemblies and devices do?
Exactly. That's their whole intention. They operate on pressure coming through, and if pressure on this side becomes greater, they're going to close off to stop the water from shooting through. And because it's a mechanical device, they need to be tested annually to make sure that everything in there is working correctly. Again, our number one resource is going to be water, and we want to protect society from drinking the contaminants that could be in those pesticides of the golf course, that could be in that soapy bucket, that could be in that muddy water, that could be in the toilet.
It's definitely something we should all be aware of. And are these assemblies as well that prevent backflow?
Yeah, these are a little bit larger, so you're going to find these where you have a larger building, possibly a hospital, could be a large commercial kitchen, or it could be a system that has fire protection on it.
And I see the ASSE designation right here, so that is something someone in a position for making selection on these devices should be looking for, because they can rest assured that these have been manufactured to the highest standards out there to protect our water supply.
That's correct. So it's going to tell the inspector that this meets the ASSE standard, and that has also been independently tested.
Well, as I'm looking at this looks pretty complicated. It must be a pretty intense course, I take it, that they must take?
You have to come into this course with at least 5 years of experience in a piping system, so you have to have a basic understanding of water, how it works, how the piping systems work. And then you're going to take a 40-hour course that's developed by ASSE, by an ASSE-approved school, by ASSE-approved instructor. You're going to finish that course. At the end of the course, you're going to take an independent exam that's created by ASSE using an ASSE-approved proctor, so it's independent from the instructor. He has nothing to do with the test, both written and hands-on, to show that the person that is trying to get certified has acquired the knowledge that he needs to test these things properly.
Sure, that's the ultimate in peace of mind, and you said it has to be an approved ASSE facility. We're here at Plumbers Local 75. This is obviously an approved facility, but this certification isn't necessarily just for union. Non-union members and any plumbing professionals can take it as well, and even inspectors from the cities.
Yeah, that's correct. ASSE is internationally renowned as a third-party certifier, which means that we have to be completely neutral from any union affiliation, non-union affiliation, independent from any kind of industry group that's out there. That's how we keep our neutrality and recognized as a third-party certifier.
I tell you, there's no substitute for health and safety, our most valued natural resource, and that's water that Mother Nature provides. So I appreciate you coming on, shedding some light to this ASSE certification in both the assemblies and the human side of it as well. So keep up the good work. Right now I'm going to catch up with Vince, one of the ASSE certified instructors, to learn more about that testing process. Well, Vince, I was just chatting with Scott, learning more about ASSE and the different certifications out there. And I understand that you guys have a course going on here today, and then the guys are taking a little break. But I wanted to catch up with you as an instructor to learn more about the testing, more about the coursework. And let's begin by explaining how you became an instructor.
Well, back in about 1999, we had a backflow course here at our local, and it was just a state certification. It grew into a 40-hour course that we have today, and then it branched out into our survey course, which is going on here today.
Boy, a 40-hour course. That sounds like a pretty intense training session.
It is. We cover assemblies, methods, and devices. We really hammer on what it takes to protect our water supply because it's a very important resource. We have a great lake out there. We want to protect that resource and be a custodian of our water.
Okay, so this course that's going on here today, what are these individuals learning?
Today they're taking a surveyor class. So in a building they'll go to each outlet of the water supply and make sure that it's protected.
Wow, as I look at this is all the classwork material that they're learning?
Yes. It's a manual created by the UA and IATMO, and they give us this material for us to use and to hand out to the students.
And so they're learning about how to properly test all the equipment Scott and I were just talking about?
How to properly test it, what we need at each individual outlet, how gauges work, and how to fill out the paperwork.
And the people that are taking this course, are they just all licensed plumbers, or who are they?
Well, plumbing professionals. Usually it's a journeyman plumber that's already been through maybe some training, 5 years, and then they're eligible to take these courses and build on their education from that point forward.
Do you find that there's city inspectors taking them as well?
City inspectors, yes. Most of our city inspectors are plumbing professionals, have been journeymen, or come from some other industry, which also has some sort of qualifications to get them that far.
So do you find it's just more on a personal level? These individuals want to raise their level of standard and become ASSE certified on this?
Yes, it's good for them as the individual and as the consumer that we have the best possibly trained workforce out there to protect our water supply.
Well, you know, what I'm learning about ASSE and what I really like about it is that they try to stay neutral and they really try to do a good job to make sure the information being taught is being learned. And as such, you're not actually even teaching this course, right?
No, I'm not actually. I do teach the courses here at our local, but you have to be a proctor also. So I'm a certified instructor and proctor, and I'm proctoring the exam tomorrow for these individuals.
And somebody watching the show today might go, well, why wouldn't you just give the test if you're the instructor? You're looking out for any conflict of interest there, right?
Exactly. You want the instructor to teach, and you want the students to be able to demonstrate what they've learned in a competent manner and pass an exam.
And that makes so much sense to me. I mean, if I go through a course, 40-hour course, very intense, and I don't have to take a test at the end, who's to say that I learned anything, that I was even paying attention? I mean, I'm sure everybody here is doing their best, but it doesn't necessarily mean that they learned what they needed to learn without taking a test.
True. With our testing procedure, there's two parts of that test. There's a practical and a written. And with the surveyor class also, there's a practical and a written. There's a bank of questions that they use for the written part, and then a practical where you have a picture, and you have to figure out exactly what's wrong with that picture and then state your answers.
How often are there tests that are going on here?
Well, tests, we do 3 to 4 classes a year. It all depends on the need for the students, and there's different courses. So we have the tester course, we have the surveyor course, and we also have a recertification course.
Well, it's great that this service exists out here. Again, it's not just union, it's not just non-union, it's any plumbing professional that wants to broaden their career and help protect our most valuable resources, the water that Mother Nature provides. Thanks for coming on.
Thanks, Stu.
Plumbers Local 75, we train people all the time, and we're very good at doing the training. But what really tests the quality of our training programs is to have third-party accreditation, so the exams that we train to are generated and proctored by an entity that is not affiliated directly with our organization. ASSE International is a true third-party accreditor, but it's a whole nother certification that will protect health and safety of the consumer and our resources.
Building Wisconsin is made possible by the members of Plumbers 75, proudly serving their contractors and helping build Wisconsin for over 100 years.
We all know the most basic form of life requires clean water to survive. On Earth, we need it to drink, cook, clean, and it touches just about every part of our quality of life. Here in Wisconsin, we appreciate the value of clean water even more as we live alongside the Great Lakes. Yet we often forget to think about how water gets to our homes, schools, and businesses, and then safely back to Mother Nature. Where does all the dirty water go? How is it fresh and clean every time we get a glass of water? Who makes this happen? The answer: plumbers. It's the plumbers who are trained, mentored on the job, and have progressed through a 5-year education program that takes them from apprenticeship to a master of their trade. It's plumbers who are committed to a career and have been trained to protect the health and safety of our water system and make sure you never have to think about where it comes from and where it's going. Yes, we're fortunate here in Wisconsin to have an abundant supply of clean, fresh water, but even more fortunate to have a highly trained and committed workforce to keep and deliver it that way.
Plumbers 75, supporting the plumbing trade in southeast Wisconsin for over 100 years. For more than 85 years, Wisconsin businesses have trusted Illingworth-Kilgust Mechanical for exceptional mechanical services. In fact, they've completed over 6,000 projects for more than 800 customers in 2015 alone. And as one of the largest companies of its kind in Wisconsin, Illingworth-Kilgust Mechanical provides a full range of customized solutions for HVAC, plumbing, and industrial piping. Illingworth-Kilgust is ASSE certified for backflow prevention and is a MSCA Green Star contractor. Illingworth-Kilgust Mechanical and Plumbers 75, proud to be building Wisconsin. For more information on Building Wisconsin, follow us on Facebook and Twitter, and be sure to watch additional episodes on YouTube or at our website. BuildingWisconsinTV.com.
Welcome back to Building Wisconsin. I'm Stuart Keith, and so far in today's show, we've been learning more about what's being done to protect our water supply. Now let's continue with City of Milwaukee Plumbing Inspector Jim Kosmatka. Well, Jim, so far in today's show, we've been learning the importance of backflow prevention devices. And as I'm learning more about this topic, I'm finding out that the city inspectors, especially here in Milwaukee, are playing a vital role in ensuring that these devices are in place to protect our water supply.
Yes, in addition to our route inspectors that are inspecting new projects and remodeling and alike at commercial and residential properties, we have a newer program, about 8 years old, that we do cross-connection surveys at all buildings in the city. It excludes 1 and 2 family dwellings, but what we do is we go through buildings, existing buildings, and we look for the entire plumbing system to be conscious, if you will, of concerns of backflow and back siphonage to contaminate our potable water, our safe water system.
And you know, sometimes building inspectors get a bad rap, and I think that's really by uneducated people that don't realize the important role you play. Because after all, you're out there to protect the end user. Whether it's new home construction, remodeling, cross connections, you're there to ensure everything's done correctly to protect the end user and the general public.
Well, obviously as an inspector, I probably am concerned more with the potential safety concerns that can happen when things are put in improperly or unsafe. There's things you can buy that you can install that are not approved, and it's not safe for our potable water. So we go out and see what people are doing and inspect what's there, make sure it's cognizant, if you will, of what can happen if things are put in wrong, or just potential of daily use of a plumbing fixture. It is a federal mandate to the city for our license to sell water that we have this safety program in place. And there's no charge for the surveys we do. We go out and we basically analyze the plumbing system and look if there's any concerns of contaminants coming in on this end, on the user end. Obviously the city goes to great measures to send out safe water, and it's been identified through the years that the water can get contaminated in the field, and that could contaminate a building or a neighborhood.
Sure. Now we're in a very large commercial building here, so there's a potential for contamination. It's probably higher than at a residential area, but it's still equally important. The awareness should be heightened at a residential level as well, right?
Well, absolutely. And in here as well, we see something that's typical to a residence. This little device threaded on here is a vacuum breaker. And wherever there's hose threads, we look. On the multifamily dwellings we do, and on the commercial buildings, if they can put a hose on there, we're concerned where can that hose go? Can they mix it with a power washer and some chemicals? Can they put it in a bucket of chemicals or blend it with something? Also, we don't want you drinking out of the hose because that water is contaminated. It may not be highly contaminated, there's different levels. However, we don't want you drinking out of the hose. That's not a safe, approved plumbing product.
Okay, and so what you're saying is, even though this is a commercial building, a vacuum breaker, this little device right here, might be something that most homeowners should be familiar with. And maybe you have a wash tub downstairs, maybe you have an outside hose bib. You're saying if you connect a hose up to that, and say you're washing your car, you have a 5-gallon pail of suds there, dirty water, phone rings, you throw that hose in the bucket, all of a sudden there's a fire down the street, or they happen to clean out the fire hydrant, that could create a back siphonage or a back pressure that sucks that contaminant into the water supply and contaminates all your neighbor's water?
Exactly, and the first thing it's going to do is go through that house, so those people may be potentially drinking that. That's our first concern. And the scenario is rare, but these potentials are there, very real, and it needs to be accounted for.
So when you enter a building like this to do an inspection, how do you start the process?
Well, every building we go into, we'll start where the water comes in at the water meter to the building, and we'll take a look where it goes, what it serves. For instance, Stu, we always do end up in the mechanical room to take a look at the piping. We do go through all the restrooms, kitchens, look at all the fixtures, see that things are state approved, compliant, safe. In here, right away we see non-potable water. Okay, this is identified, this is the water supply connected to the city water supply, but it's non-potable here.
And non-potable means you can't drink it.
Correct.
Whereas potable you can. Some people say potable, some people say potable.
Right.
But regardless, non-potable, don't be drinking it.
Right, you can see this is hooked up to the same process where this glyco is, okay? Now what we need to do is go back and verify that this pipe is identified with the yellow bands and or unsafe verbiage, non-potable, back to the high hazard backflow preventer where you can continually get the water supply to this fixture, but if pressure is lost on the supply end, that valve closes, dumps on the floor what might be downstream in the system, and our safe drinking water continues safe.
Because if you didn't have that device there, you run the potential of glycol entering not only this system, but other systems throughout our community.
Well, correct. If pressure's lost at the street, this water, just by gravity, this contaminated water will flow down into the street to the water supplies. So we have that isolation device that stops it at the backflow preventer that you've seen, I believe, at other locations. And we depend a lot on the facilities people to work with us, and we have a great relationship. For example, I come into a place often where there's been a maintenance head there for 20 and 30 years, and he'll take me around. He's passionate about his place, show me what they have, we'll communicate, and sometimes I have to say, you need to get a plumber in here to identify this or pipe this properly or install the proper backflow protection.
How often do you actually run into something that's changed?
Well, for us it starts out that it's a federal mandate that we have the safety program, and the inspectors have a couple thousand places to go through. And we might go in a place 4 years later, that might become a different business, and they change what they have for a plumbing system. Things are altered. I mean, for example, recently we had a place where they added a coffee maker. Someone came in, they remodeled an office a little bit, wanted something somewhere else. And then there was complaints of how this coffee tasted, and it was discovered when they looked where the vendor went up in the ceiling and tied into a 3/4 copper line. That wasn't a cold or hot water line. That was a hydronic heating line with chemicals, with antifreeze.
Glycol or antifreeze, yeah.
And so luckily they identified that in a hurry, and nobody got significantly sick or ill. I recently did a building, and there's 120 of these high hazard backflow protection devices in, and I know of other buildings where there's significantly more. You start to get into bigger buildings, hospitals, etc.
Well, Jim, I really appreciate you coming on today's show and heightening our awareness to the importance of the backflow prevention devices and really your role as an inspector and all your cohorts out there protecting our vital water supply. Right now I'm going to learn more about the specifics of the testing of a backflow prevention device as I catch up with Andy from Kilgust.
All right, Stu, it's been my pleasure.
Hey Andy, I just had a chance to go through the inspection process with Jim, and he stressed the importance of testing the cross-connect or really the backflow prevention on these systems. And is this what I'm looking at right here? This is a backflow preventer?
Yep, this is a backflow preventer assembly right here from this valve to this valve. It's got a check valve in here, a check valve in here, and a relief vent there to prevent backflow from across the non-potable water to the potable water system.
Okay, and so it looks like you're getting set up to test it to make sure it's operating correctly?
Yep, that's correct. I'm going to set up my test with my test gauge here. We're going to test it through these ports, and we're going to make sure that this check valve shuts off the way it's supposed to, shuts off nice and tight to prevent flow. Same with this check valve, and that the relief vent actually opens up to dump the water.
Okay, so before we get into that process, let's just step back and explain what we're looking at here. Because when I came into this building, this is a pretty large building in downtown Milwaukee.
This building has a bunch of HVAC equipment for the heating and the cooling, and it has makeup water. So the potable water, which is drinking water, comes down this side, flows through this backflow preventer and into the non-potable side. In this side, they add glycol, which is a chemical to help protect their piping system for the HVAC system, which we would not want to drink. So we want to make sure that that glycol water doesn't come back into the potable water side on this side, and this valve is going to do that for us.
Okay, so the flow is coming down here through the backflow preventer, but then it splits right here and continues up that way and down this way?
Yep, so once it's on this side of the backflow preventer, it becomes non-potable water, which is non-drinking water, and then it goes and it feeds several different pieces of equipment. So where it splits here and goes down, it feeds a piece of equipment on the floor below us, and then it continues up into the ceiling area here and feeds other equipment on this floor.
And because there's glycol mixed in here, and again, in any other commercial building, it might be acids or a lot of nasty stuff. If you didn't have this device and you got maybe a negative pressure on this side, it could suck all that back into our water supply?
Yep, you can get back pressure from the equipment maybe creating pressure, which is pushing it through, or you could get like a water main break, which would suck the water through, and this valve's going to stop that from happening so that we don't have to have all that nastiness in our good potable water.
So how often do these backflow assemblies need to be tested?
A backflow preventer needs to be tested annually. So once a year, and we do the test to make sure that everything's working in there. And then the other time that you would test it is if it's not operating appropriately. So if a maintenance facilities director comes through and sees that it's leaking out the relief vent here, and he notices that it's dripping steadily or something like that, then he would call in the plumber or the tester to come in and test that backflow assembly to make sure it's working correct.
Is there a master list out there, or who ensures that these are getting inspected on a regular basis?
Sure. So when you put in a backflow preventer, you do your test on it, and you have to register it with the state of Wisconsin. They give you this RO number, which is a registered object number, and then they have a database that you can go onto on the website, and it has a serial number with the backflow preventer that matches with the RO number, and that's open to the public, so anybody could get on that list and see and make sure that all these backflow preventers are being tested annually.
I mean, I got to believe there's thousands of these throughout our state. I mean, just in this building alone, how many of these are there?
Just in this building, this particular building alone, we have about 10 of these in this building, but different buildings have different numbers of them. Some may have 1, some may have 20. It depends on what they're manufacturing or doing in the building.
Okay, well, let's get into the testing process itself. What are you looking at here?
Well, first I got to set up my test gauge, and I'll hook up my test gauge to test cock 1. Once I get that nice and tight, I'm going to flow some water through my test gauge.
And what does the test gauge actually measure?
The test gauge is actually going to measure spring tension pressure on the check valve inside. Inside this backflow preventer, there's 2 check valves and a relief vent, and each one has a spring on it. So then I'm going to shut the flow off to the backflow preventer, and we're going to open up the test cock number 2, and we're going to watch the flow come out. We just kind of watch that, and once that water stops, that's going to tell me that that check valve has seated tight, and I'm going to check my gauge, and my gauge is going to tell me what the spring tension pressure is. As long as that spring tension pressure on check valve number 1 is over 5, I'm going to be good, and the water stops.
So as I look at this, I see the water. This one's working fine, but what happens when you find something that's faulty in there, or else your gauge is telling you that it's failing?
If my gauge says the spring tension is too low, or if the check doesn't hold, then I go ahead and I can open it up and I can get replacement parts and we rebuild the check valve.
Well, obviously a very important piece of equipment, not only for this building, but for our society as a whole. We only have one water supply. We want to keep protecting it. Thanks for coming on today's show and explaining the testing process.
It's been my pleasure.
The preceding program was sponsored by the Building Wisconsin Television Network.